Hello, this is Mr. Stansbury. I'm going to take you through the notes on two-column geometric proofs. Okay. At the end of this, you should be able to say, I can complete two-column proofs to prove theorems about segments and angles. Okay, so let's take a look at a proof here. We're going to take a look at trying to prove that vertical angles are congruent. Okay, so given that angle 1 and angle 2 are vertical angles, prove that angle 1 is congruent to angle 2. So first thing we want to pretty much always put down is what they give us, right? So we will do angle 1 and angle 2 are vertical angles, and our reason for that given, right? So if angle 1 and angle 2 are vertical angles, we're trying to prove that angle 1 is congruent to angle 2. So if we can take a look here, notice that we have a straight line there. Let's go with this. If we know that the measure of angle 1 and the measure of angle 3 has to equal 180 degrees because it's a straight angle, right? Or straight line. Okay, so we know that those two have to be supplementary. And the reason why we know that is because that's the definition of supplementary angles, right? So let's put that in there. Okay, so then next thing we want to do is we also know that angle 2 and angle 3 are also supplementary angles, right? So let's go with that. Angle 3 and angle 2 have to equal 180 degrees, also because of definition of supplementary angles, right? So let's write that in 2, okay? And then next here, what we can do is since we have both of these things here equal to 180, we can just put this here in for that, because 180 equals measure of angle 1 plus measure of angle 3, or measure of angle 3 plus measure of angle 2 is also equal to 180, so we can put those in for each other, right? So it looks like this measure of angle 1 plus measure of angle 3 is going to equal measure of angle 3 plus the measure of angle 2. And really what we did there is we just took the 180 out and we substituted measure of angle 2 plus measure of angle 3, so that would be substitution, right? So substitution property. All right, so now we're getting somewhere. So now what we want to do is, if we get rid of these measure of angle 3's from both sides, then we're in business, right? So we subtract the measure of angle 3 from both sides, and we get measure of angle 1 equals measure of angle 2, and that is our subtraction property, right? Okay, so subtraction property of equality is the full name. Subtraction property would be just fine. Okay, and so now that we know that the measure of angle 1 is equal to the measure of angle 2, then we know that angle 1 and angle 2 have to be congruent because of our congruent angles, our definition of congruent angles, right? So we know angle 1 has got to be congruent to angle 2 by definition of congruent angles. Okay, and that is our first geometric proof that we've done, at least in this class. So that's what a geometric proof looks like. It's really just kind of trying to figure out a way to go through and prove, like show step by step how these two angles here would be congruent. We'll go through a bunch of these together, making sure that we have that all down. Okay. Okay, so let's try another one here. Here's number 6. So write a two-column proof. Given that ray BD bisects angle ABC, and also that the measure of DBC equals 90 degrees, prove that angle ABC is a straight angle. So BD bisects angle ABC, and then we know that the measure of angle DBC is a right angle. Prove that angle ABC is a straight angle. Okay, so first thing we want to start with is that BD bisects angle ABC. That's one of our givens, right? So given, oops, should make it so we can read it. That's better. Okay, and then let's see. Since we have that, we know that since it says that it bisects angle ABC, we know that angle ABD and ABC have to be congruent, right? So angle ABD is congruent to angle DBC, and that's because it's a angle bisector, right? So that's just going to be our definition of angle bisector. Okay, definition angle bisector for that one. So then the next thing we could go with is that since we know that angle ABD is congruent to angle DBC, then we can say that their measures have to be the same as well. So measure of angle ABD is going to be equal to the measure of angle DBC. Okay, so the reason why we know that is because since these angles are congruent, their measures have to be the same. So definition of congruent angles, right? And then next from that, since we know that angle ABD and DBC have the same angle measures, we know that the measure of angle DBC is 90 degrees. That right there is our second given. So we were given that piece of information, so we just write given on that. Okay, and then, so since we know that, we know that the measure of angle ABD also has to equal 90 degrees, right? Measure of angle ABD also has to equal 90 degrees because of we could call that like the transitive property, because if ABD is congruent to DBC, then we know that those have to be both equal to 90 degrees. Another way really could be, I mean, honestly, I could look at that also as like a substitution, because ABD is equal to DBC. So we take the DBC out and put the ABD in. So transitive property, really, or substitution, I think either one of those would work fine there. Let's go with transitive property. Okay. And then, since we know that the measure of angle ABC, this whole angle here has to be the measure of ABD and DBC together, right? Because of the angle addition postulate, right? So we know measure of angle ABC is going to equal the measure of angle ABD plus DBC, and again, that's the angle addition postulate. All right. Okay, we're getting there. Some of these proofs really take a long time. It's okay. We'll walk through several of these together just to make sure that we're doing okay. All right. Next thing we can figure out is, since we know that measure of angle ABD and measure of angle DBC from both of these up here, we can put 90 degrees in for both of those there, right? And so we're basically just taking the ABD out and substituting the 90 in for both of those. Right, so it would look like this. Measure of angle ABC is equal to 90 plus 90, which equals 180 degrees, right? And that is just substitution property, all right? And then that there, we're saying that measure of angle ABC is equal to 180 degrees, right? So that means that angle ABC has to be a straight line, right? So angle ABC is a straight line, which is what we're trying to prove, okay? And we can say that because of definition of a straight angle. Okay, so that was a big one. That took 8 steps to get all the way through that. So again, we'll talk about more of these together in class, just to make sure that we're doing okay on these. Okay, so if you have any further questions on any of this stuff, please feel free to ask in class. Thanks.